Swayam Prabha. Digital India. Educated India.
So, hello everyone. So, we have reached almost to the last part of UV protective textiles. Here we will be discussing on the study report which studied the effect of yarn twist, modified yarn structure. So, we have modified the yarn structure to make the yarn hollow. So, normal ring spun yarn in the core, the water soluble PVA fiber is used, okay. And after making the yarn, core spun yarn, when it is treated with the warm water, this PVA gets dissolved and the cotton hollow yarn portion will be there. So, that modified yarn structure characteristics we studied, and what is its effect on the UPF characteristics. Okay. This hollow yarn, the main difference would be if we make the hollow yarn. So, we have the for same yarn linear density, the diameter will be high. So, it will cover more pores openings, and also at the same time after the hollowness is created, the hollow yarn can get flattened. So, that will enhance the covering of the pore openings, okay, that we will discuss, and also we will discuss the fabric thickness. So, keeping the fabric linear areal density constant. So, if we want to reduce the fabric thickness or change the fabric thickness is basically is a function of the yarn diameter. So, yarn linear density, coarser yarn will result higher thickness, and fabric areal density is a function of yarn linear density as well as yarn closeness, that is fabric set, the ends or peaks per unit area. So, here we have used one approach, that means suppose we want to reduce the thickness keeping the fabric mass per unit area same, areal density same. So, if we want to reduce the thickness, so we have to use the finer yarn, and at the same time as compared to coarser yarn we are using finer yarn to reduce the thickness, but to keep the areal density same. So, we have to increase the closeness of the thread. So, fabric that yarn packing in the yarn fabric structure has to be more. So, in that case the main difference would be that the pore dimension, pores size of the pores will be reduced. So, in case of coarser yarn, the size of the pore will be larger between the yarn. So, these are the yarns. Okay. So, between the yarns, these are the yarns, between the yarns warp and weft yarn, this is the size. So, individual pores size will be more in case of coarser yarn, and it will become smaller in case of finer yarn. So, that effect we are trying to explore here. So, first let us discuss the effect of yarn twist. So, if we change the yarn twist, so if we increase the yarn twist, that actually has two effects on yarn property, yarn characteristics. So, for staple yarn, if we increase the yarn twist, yarn diameter reduces, and at the same time hairiness of yarn increases with the increase in yarn twist for ring spun yarn, and we have used cotton, 100% cotton we have used here. So, hairiness increases and yarn diameter reduces, and then we have developed fabric. So, fabric cover is measured, and then the fabric is tested by scattering of UV ray, and fabric UPF is measured. So, when yarn is twisted, suppose this is the low twisted yarn, yarn diameter will be more, and at the same time hairiness will also be less. Okay. Now, for the same yarn and same thread density, if we increase the yarn twist, so yarn diameter will be reduced. So, yarn diameter is reduced. So, apparently it appears that the pore size is increased. So, UV ray can pass through. So, with the increase in yarn twist, apparently it appeared. So, what was initial assumption was that fabric UPF should drop, but another impact of yarn hairiness came. So, yarn hairiness, if it is increased at high twisted yarn, so this will actually, these hairs will try to block the pores and the UV ray will get scattered. So, let us see the impact of this, the opposite phenomena, two opposite phenomena, reduction in yarn diameter and increase in yarn hairiness, how the UPF gets affected. So, we have used 100% cotton roving of 0.8 any count. Now, sample preparation. So, we have prepared 3 yarns. Okay. So, yarn count we kept constant, and draft which we have used 27.44 to produce yarn count of 20 any, and twist multiplier which we have used 3.6, 3.9 and 4.2. So, twist multiplier has increased, and from there we have produced 12 woven fabrics of plain weave fabric. We kept the yarn density per inch 50 ends per inch, and twist multiplier we have taken 3 twist multiplier, and we have produced fabrics 12 fabrics with, for each twist multiplier we have varied the peak density 40, 50, 60 and 70. This peak density, so with this combination we have produced 12 fabrics. Then we have measured the yarn diameter first after twisting. So, as the twist multiplier increases, so level of twist increases, yarn diameter consistently reduces, which is normal and which is expected. So, with the increase in twist, yarn becomes compact and yarn diameter reduces, and accordingly the fabric thickness, typically the trend is that although the changes are not that significant, but there is a little decreasing trend, but in few cases the trend is not that visible. Now, fabric areal density, there is no specific trend observed. So, it is almost there is no specific change, significant change is there in fabric areal density, but with the peak density the fabric areal density increases consistently. So, which is normal, higher dense peak density will result higher linear areal density, but the twist multiplier does not have any significant effect on this. Now, if we see the ultraviolet protection factor, here there is no significant trend, significant effect of twist multiplier on UPF. So, the reasons are basically, as we have discussed, with the increase in twist, the chances of UV ray passing through the yarn portion is reduced because of the compact yarn structure. Although there is a opening between the yarn, the gap is there between the yarn, there is a gap is increased due to the reduction of yarn diameter, but as hairiness increases with the increase in twist, so that to some extent blocks. So, this opposite phenomena comes together, and that results that insignificant effect of twist multiplier on UPF of fabric. So, no specific trend has been observed on UPF with increase in twist level. That was our observation. So, this is the ANOVA table. Now, our next part is that effect of hollow yarn structure. So, we will discuss the how the hollow yarn structure changes the UPF value. So, the advantages of hollow yarns are the hollow yarn with the same linear density equal count, hollow ions will have higher outer diameter than normal ion, that we have discussed. This is the solid ion, cotton ion, and to keep the same ion count, this is hollow ion. Hollow ion will have higher diameter, which will result better covering. So, MH is proportional to pi d square d1 square minus d2 square by 4, where MH and MS are the mass per unit length of hollow and normal ion. So, this is the mass per unit length. So, direct count we can say, and which is proportional to the, for hollow ion, d1 square, d1 is the outer diameter, this is the outer diameter d1, and this is the hollowness d2. So, d1 and d2 are the outer and inner diameter of hollow ion respectively, and d is the diameter of the solid ion. Here if the, in this case say MH, mass per unit area, unit length of hollow ion, if they are equal, if it has to be equal, then d1 has to be more than d. Here is the diameter is d. So, for the same count, that means MH equal to MS. So, in this case, so pi d1 square minus d2 square by 4 equal to pi d square by 4. So, this is the proportional factor. So, from this equation d1 square minus d2 square equal to d1 square. So, as there is hollowness, so if we increase the hollowness as d2 increases, d2 is increasing, to keep the equation intact. So, d1 has to increase, has to be more. So, more the hollowness, higher will be the outer diameter, and that will affect the compactness, that is closeness of the threads. Now, try to understand here. This is the PVA coarse spun yarn, where d1 is the outer diameter and d2 is the inner diameter. So, d2 inner diameter, and when this core PVA is removed by dissolving, this portion becomes hollow. Hollowness, the width of the hollowness is the inner diameter of the hollow yarn, that is d2. And when after the finishing or calendering, this hollow yarn becomes flattened, which will enhance the effective width of the yarn to a greater extent. In normal yarn also, gets flattened, but not at that extent. There is a flattening, little bit elliptical shape will be there, but effective width of the hollow yarn is much higher than the normal yarn. So, here the flattening of yarns, this one is PVA coarse spun yarn, and here is the B is the normal yarn. So, compressibility of hollow yarn will be higher than the normal yarn. So, hollow yarn will give better flattening as compared to the normal yarn, and it will give the better cover. So, hollow yarn will have better covering power, which will cover the pores between the yarns. So, what is the experimental plan? So, what we have used 100% cotton roving 0.8 Ne. So, polyvinyl alcohol multifilament yarn we have used 20 Ne we have used, and that is produced in the ring spinning. So, both normal yarn and core yarn was produced, and core yarn count was 10 count. That means, core yarn 20 Ne is the polyvinyl alcohol core, and sheath cotton component will be again 20 Ne. So, if we use the coarse spun yarn we produce, so effectively it will be 10 Ne coarse spun yarn, but after washing this is PVA and this is cotton sheath PVA core. So, after washing this portion will be removed, only the cotton sheath portion will remain, this the PVA will be washed away, the sheath portion will be there, and this sheath portion will result hollow yarn. So, here what we have kept in the spinning draft, we have kept 27.44 for the roving cotton roving, to bring it the cotton content equal to 20 Ne as a sheath. Twist multiplier we have used 4.2 and 2 yarn counts were produced. So, normal yarn we have produced 20 Ne, normal cotton yarn 20 Ne we produced, and coarse sheath yarn we have produced 10 Ne with ratio 50:50, PVA and cotton ratio, coarse sheath ratio 50:50. So, this is the schematic diagram of ring spinning method using for producing coarse spun yarn. So, the staple fiber roving, that is cotton roving is drafted by 3/3 drafting system in the ring spinning, and the PVA filament is actually in the drafting roller just at the front roller drafting, through the front roller drafting it is placed, and the sheath fiber will wrap around this PVA filament. So, that was the idea to make coarse spun yarn. Now, if we see the cross section of the yarn which we have produced, so that we will see that perfect coarse spun yarn was produced, and from this yarn we have developed 8 fabrics. So, these are the different fabric structures. The weave is the plain weave we have produced. So, N density is 50 and with normal yarn 20 is yarn and 20 coarse spun yarn we have used. With a normal yarn we have produced fabric 4 fabrics with 4 different peak density 20, 30, 40, 50 and similarly for coarse spun yarn. So, total 8 fabrics were produced. Now, after weaving what we have done? We have done desizing, scouring and bleaching. During this wet treatment at the elevated temperature the PVA fiber got dissolved, okay, and this the washed out from the core and sheath cotton fibers remain. And after the wet treatment the fabrics were calendared and which allows the further flattening of the yarns. For normal yarn the flattening will be less and for core yarn flattening will be high. Now, if we see the fabric cross section of fabric after weaving with PVA core fiber. So, before washing if we see here the PVA core filaments are easily visible. This is the core spun yarn. So, PVA filaments in the core which is very well visible here, and the fabric cross section after scouring. So, when PVA got dissolved, so hollow portion remains. So, you can see this is a hollow portion here where PVA has been removed. So, hollow core yarn is there. Now, see the fabric cross section after ironing. So, after ironing the hollow yarn, the core spun yarn, that is after ironing we can see the flattening, level of flattening, the width of the yarn is increased, and here we will see that there is effectively no gap between the yarns. So, earlier before washing you can see there is a clear gap between the yarns, okay. Clear gaps are there between the yarn surface, but when we after flattening or after ironing the yarns become very flat. So, effective covering has increased a lot. On the other hand, the normal yarn it is although flattened, but there is still some space available in between the yarns. The flattening is there, but not to that extent, and also yarns are very compact. So, yarn diameter are less. Here due to the hollowness the flattening and diameter, effective diameter was high. So, that actually helped in perfect blocking of the pores, keeping the ideal density of the fabric constant. Now, what are the results? So, yarn diameter, that is measure axis in fabric after flattening. So, you can see the yarn diameter for normal yarn. The yarn diameter was 0.368. For core yarn, it has become 0.502, and the increase is 36.3% increase in yarn diameter from normal to core yarn due to presence of the core component. So, yarn diameter is higher in case of core yarn than the normal yarn. Now, fabric cover factor, here the normal yarn cover percent was 66% and the coarse spun yarn with the hollow yarn, it is 71% for 20 peak density, and for higher peak density, both for normal yarn and the core yarn increases here. So, always fabric cover is higher in case of core yarn for all the peak densities. So, fabric cover is better in case of core yarn. Now, fabric aerial density, if we see, fabric aerial density, there is no specific trend, there is no significant difference is there, but although the core yarn gives little bit lower aerial density, that may be due to the stability and all the distortion. But no clear trend is observed. Now, try to see the UPF value. So, with the increase in peak density, for normal yarn UPF value increases, and for core yarn also it is increasing, and core yarn has got higher UPF than the equivalent normal yarn for same GSM, keeping all other parameters same, yarn count same, peak density same, end density same. So, this is interesting that core yarn is always giving the higher UPF value, that is basically clearly due to the flattening and the covering of the threads, covering of the open space, as I have already mentioned. But one very interesting thing we can observe here, the percentage increase in UPF value. So, percentage increase in UPF value, if you see for 20 count, for 20 peak density, that is for open structure, so only we are changing the peak. So, I will draw only the peak for open structure. These are the waved yarns. As compared to normal yarn, the core spun yarn has only 2.5% increase, but when we are using the closed yarn to yarn distance becomes less, that is peak density is high. This is the high peak density, here is the 20 peak density, this is 50 peak density. So, here if we see is compared to normal yarn, the core yarn's UPF has increased a lot, 19.6% as compared to 2.5% in case of 20's count. So, in both the cases, in 20 peak density and 50 peak density, in both the cases there will be flattening in case of core spun yarn, but we tried to understand why in case of compact fabric the peak density in UPF has increased in that to a greater extent, and this trend is consistent as the fabric becomes compact, peak density increases, the percent increase in UPF consistently increases, and suddenly from 40 to 50 peak density, at higher peak density it is very high. So, that trend we tried to analyze here. So, when we started taking the photograph of image of the fabrics, we can see at normal, this is the normal yarn, core spun yarn with the 20 peaks per inch. In normal yarn the openings are much more than the corresponding the core yarn, because it is a flattened properly. So, the size of the pores have reduced little bit. So, there is a increase in UPF value. So, this is 2 point, here UPF value is 3.64 and in this case UPF value 3 point normal yarn 3.55 UPF. So, it has increased, 2.5% increase is there. So, at low level of cover with the say 20 PPI, the enhancement in UPF is very small. However, it gets amplified as the cover increases. So, this effect of the flattening or effect of the hollowness, this gets amplified as we have seen here. So, at low cover most of the UV is transmitted through the pores, thus the effect of the core yarn is very minor. So, at low cover, so that openings are there. So, most of the UV rays are transmitted through the openings. So, flattening effect has lesser effect, lesser significance here. As the cover factor increases, so as at high cover factor the transmission is low. So, if we increase the peak density, transmission of ultraviolet ray itself reduces, thus even a small increment in cover which leads to further reduction in transmission and which is significant. So, at higher cover factor this increase will be that it will be significant increase, and what we have done, we have treated the fabric with UV finish treatment. So, let us see after UV finish treatment, this increase has actually, the percentage increase from the normal yarn to core yarn has been magnified. So, earlier it was around 2.5%. So, you can see this is 2.5% has become 4.7%, like for every all the situation this has increased, and for normal yarns this UPF value increases, for core yarn also it is increasing, and their percent increase has also magnified. So, due to the ultraviolet finish treatment, the treatment component has also absorbed. So, that is actually that results a higher UPF value. So, this now fabric with hollow yarn structure give higher UPF compared to the fabric with normal yarn, that is true for without treatment and with treatment. The difference becomes more prominent at higher cover factor. This is also true for without treatment. Also the difference is amplified, this difference amplified by UV finish treatment, that is important. So, this difference here you can see it is. So, here when we are treating with the UV finish, the yarn component, that is blocking the yarn portion which are blocked, which are blocking the free flow of this UV ray. So, if after finishing the yarn component will 100% block, because of the finish treatment is there, only the chance is there for UV to get transmitted only through the pores available. But in case of unfinished untreated fabric, the UV ray can move through the yarns also. So, that is why it is getting amplified. So, UV finish improves the UV absorption of the fibers, the fiber gets fiber also absorbs the UV ray, thus the transmission through the yarn becomes non-existent. So, through yarn the UV transmission will not be there. So, the effect of core yarn which leads to the higher cover gets amplified. So, here the when the in case of core yarn, this is normal yarn, core yarn, it gets flattened. So, normal yarn and core yarn. So, through this portion the UV ray cannot pass. So, that is why this increase is magnified, it is amplified. And our next part is that its effect of fabric thickness for same cover. We try to keep the fabric cover same, but we have changed the fabric thickness. Okay. That we will discuss in the next session. Till then, thank you.